Let me try to explain the challenges and difficulties that you will face in this course. I will describe the most fundamental challenges that many of you will face. So, first of all, this is not an easy subject. It includes many things like a maths, it includes Boolean algebras, it includes drawing skills for logic schematic, and also it includes learning a language for describing hardware. So you will be picking up a brand new language here for completion of the projects. However, that language is not part of your theoretical study. It don't appear in your quiz or exam or anything, but still you need to learn it as a sideline activities along with this course. That means you have to have some extra effort on top of whatever challenges it poses, right? So that's couple of things. Apart from the fact this is an hardware centric study, we are computer science people. It is sometimes become too abstract to deal with the concept. However, if you stick to the lectures and notes, and if you keep on asking questions to clarify your ideas, it should not be a problem. Okay. But most basic challenges that you'll face is that you'll need to coordinate between many of your skills like drawing skill, math skill, Boolean algebraic skill, programming language pickups, and so on and so forth. So that's pretty challenging environment. Only one basic process is there to overcome these challenges. It's practice, practice, and more practice. Practice on schematic and logic diagram drawing, practice on the math problems, Boolean algebraic problem. At least do those examples shown in the class. Do those which are as given as a practice problem set. So exam will be all about brain and hand coordination. Like it's if you do practice, exam won't be that difficult. Okay, if you do not practice, it will be a really bad experience for you. As I said earlier, exams are going to be difficult exam. Okay, so you need a lot of practice throughout this semester. I have a simple study time rule. It's a 4x study time rule, which means the amount of time you are spending within the class time, multiply that time with 4, and that's the amount of time you need to spend outside the class time. For example, our class meets for uh, 2 hour 30 minute, 2.5 hour per week, right? 1 hour 15-minute class, 2 days. So it becomes 2.5 hour of total class time we spend online or in class, doesn't matter. We spend together. So you need to spend 4 into 2.5 hour, which is 10 hours to per week at least outside this class hour. So you need to spend that much of time. Of course, like you need them. You need the time to learn a new language for the project. You need to practice your drawings and maths and Boolean algebras. And of course, you need to spend time to study the material up front. In this class, I will not go through the lecture slides and do a lecture and you listen, I do lecture. It's not the mode that we'll go through. What will happen is that you watch the lecture videos and study the lecture notes before attending the class, and in the class we discuss your difficulties in understanding queries, we do some problems together, explain new concepts, and so on and so forth. But main teaching, actually it's more like a self-guided teaching in a flip method, that you prepare yourself first before coming to the class. At this point, let us look at the last semester score and class performance for this 147. If you look at this distribution, we'll see that almost 50% of the class got A minus or better. In fact, the number of A plus is the highest in the class. The 17 student got it. Also, A is number 10. So together there are 27 student, which is quite a high. So what does it mean? This means that even if you think or perceive that this course is very hard and very tough one, it's not that it is not hard, but if you put your sincere effort in this course and follow the guideline, spend hours behind this course, you can get a good score in this course. So that's what this distribution actually proves, that even though this class is perceived as one of the hardest class, but you can still do better. Now about this study flow, it's a general guideline how your typical day or week would look like while you are taking the course. Okay, so you check the canvas for upcoming lecture schedule. Is there any upcoming lecture and lab? Like there can be exams and all this stuff. But if there is an upcoming lecture and lab, view the corresponding lecture and lab videos. So at this point, let me just clarify that we have two section of, or I won't say section, two part of the whole study. One is a lecture, it is a theoretical part, theoretical study that will appear in the exam and all this stuff. But lab is a module 10, the last module, but we'll perform it throughout the year. It basically gives you the Verilog tutorial crash courses. So each day I have scheduled some lab to you so that you can pick up the Verilog language, which is not a part of the final exam or any other exam or quiz, but you need that for completion of your project. So that's also, labs are also very important. So you view corresponding lecture and lab videos, all are in Canvas. Review corresponding lecture notes, perform the lab experiment. Now, if I'm pretty sure you'll have many questions and queries, some things are not very clear to you, so on and so forth. So add all those queries to the corresponding module discussion. So I know before coming to the class what kind of issues you are facing, so that I can address them effectively in the class. Okay, so please add your queries to the corresponding module before coming to the class, at least a day before, so that I know what kinds of things are coming up. Then join the class meeting through the Zoom. So see the process difference. You're not just coming to the class meeting through the Zoom and do rest of the things after the class. You have a pre-work to do. You have a lot of pre-work to do even before you coming to the class. You have to view all the lecture videos and lab videos, review the corresponding lecture note, perform the lab experiment. Now if you have queries, add the queries to the module discussion, then come prepared in the class meeting, right? In that way also, if there is a pop quiz in the class, it's very likely that you will do better if you prepare yourself. Now after the class, re-review the lecture notes and videos if needed. It is to kind of like, let's say you have queries, doubts, you have difficulties in understanding. Then if you go back to that after we have done with the discussion and addressed your issues, then it will be a study under a new light that will help you to better understand the whole topic. So go and re-review lecture notes and video if needed. Then practice problem set if available. So some modules has some certain problem set I have given. Solutions are there also, but point is that you do try the problems yourself first. Okay, and then you can consult the solution set and look at if your approach is good, your answer is good or not, and how to approach the problem, so on and so forth. But do the practice problem yourself first. Then it go back to that loop. Is there any upcoming lecture, lab, and whole thing starts again. Now, if there is no, ask yourself, is it end of the semester? No. So probably there are some more upcoming classes coming up. Please check the canvas carefully, and you will find there are some, and go into the loop, right? So that means throughout the semester, you basically, there are, I think, 23 lecture schedule, maybe 24. It's 23. I'm pretty sure it's 23. 23 lectures are scheduled. So this loop will go up till 23 times, 2 times per week, because there are 2 lectures per week scheduled. So 2 times per week, except for the last week, probably it's 1 lecture. Otherwise, it won't be 23. So this will be the ordeal for your throughout the semester. Now, if it is the end of the semester, we'll know what's in the stake. It's a party time, and that's end of your semester study. So that's all about the challenges and how to mitigate the problems. If you have any question, please send me email or ask me in the class.